Good afternoon once again. Welcome to our class today. We're going to talk about data and data structures. I assume that all of you have downloaded R and R Studio to your machine, to your computers. Okay, by way of review, we said that when this is an RMD file, okay, and you can see that in the file extension .rmd. And when you open an RMD file, it has this, at the top of the page, you have this YAML. The yet another, remember the name of this is yet another markup language, YAML, and it's supposed to be a generic guide on how the data, the file, or the data, the file will be knitted to R. Okay, so we have the title, output, and you can put other, for example, let me see. Okay, no, I will not discuss that first. Okay, so later on, as we go along, we're going to migrate from RMD2, as I mentioned last time, to Quarto, which is more powerful. But I just want you to have a taste of how to use R Markdown also, so that you'll be knowledgeable of both outputs, either Quarto or RMD file. Okay, so this is a code chunk. Remember, a code chunk. Okay, let me annotate. So as we said, this is a code chunk. Okay, sorry for the crude. I think I should. My digital pad is not set up. So anyway, so this is a code chunk, and we know that a code chunk is generated by this backticks and this backticks. Open 3 backticks at the start and 3 backticks at the end. And then we have these curly brackets and then R. That's a standard. This one is the name of this code chunk. We said that it's important to give a name to your code chunk because if you're working with a huge file and then you have so many code chunks, it will be very difficult for you to find a particular code chunk. So this specific file that we're using, if we take a look at this one here, you see the scroll bars here. Okay. If I click this, you see this, and you see this chunk 1 set up, and I think there's another chunk here. Okay, chunk 2. Okay, it doesn't have a name, so it's best to give names to your chunk so that you can easily access that. Okay, as I said, imagine if you have a very huge file containing so many thousands of lines, it will be very difficult to navigate through your file and look for a particular code chunk that you might need. So this is not a good practice, chunk 2. This one is a good practice, chunk 1 setup. Okay, so if I click this one, it will bring me to this chunk 1. If I click that chunk 2, okay, if I click this chunk 2 here, it will navigate through the second code chunk in this file. So as early as now, it's always good to have good practice in setting up your RMD file. Okay, and this is just an additional function, include. So is equal to false. It means that when you knit this file, this one will not be shown. Okay, the output of this will not be shown. We'll have more of this as we go along. All right, so as I said, today we're going to discuss data classes and data structures. So we first discuss what a data class is. Now, this is very important for us to have a strong appreciation of the functionalities of R. When in this subject, we're going to deal with data, different data types, different data classes, and data structures. Mostly for data structures, we're going to use a data frame or tables, which I'm going to explain later. So as I said here, it's important to have a strong understanding of the basic data types and data structures and how to operate on them. Now, in R, when you generate data or when you import data to R, they will be treated as objects. Okay, so take note of that. We will, when you generate a data or an object in R, it will be appearing here. It will appear here. Okay, so before I continue, most probably your appearance of your R Markdown is different from mine. Okay, so may tanong how, sir? Is it okay if you clear the drawings for now? Yes, yes. I'm going to remove that soon. Okay.
Sir, how do you make it dark mode po? Because mine is white.
Yeah. Okay, that's what I'm going to do now.
Okay.
All right. Sige. Thank you for that question. Annotate. I'll clear all drawings. Okay. Close this. All right. So if you want to change the appearance of your window panes, so you just go to tools here, tools, and then here you have global options below. Global options. So you go to tools, global options, and then on the tab here, okay, in the pane here you have this appearance, panel layout, etc. You notice that you can already use R Studio for Python. Okay, we said that this is another software that we're going to use, and we can use R Studio to write Python codes. But now we're using R Markdown. Okay, so let me go to appearance, and then here you have the editor theme. Okay, if you use clouds, it will be white. Okay, so these are the different appearances, different themes. Personally, I use Cobalt. Okay, I prefer this, but of course, you may use your own. Okay, you can explore what the others look like. And then the editor font size, for you to see the codes here, I'm using 16. And then for the editor font, again, it's up to you to use. I'm using the Lucida console. Okay, zoom is 100%. I can, of course, change this to 110%. Okay, and then once you do that, you apply. Okay, so you can see now that the font increased. And also, how about the pane layout? So this is the pane layout. The default is that you have the source window here and the console is below. Personally, I prefer the console to be on the upper right. Why? Because when I type some codes here, the results, the output, will also be reflected in the console. And if it's down below, it's quite difficult to see the output below as compared to one that's on the right side. Okay, so it's easier to see the output. If it's below, then maybe you have to still scroll the scroll bar below before you can see the output. But if it's on the right side, then it's very easy. So it's more for convenience sake. So how do you change your pane layout position? So supposing your environment is here. Okay, so you just click this, and then what will appear here will be the other panes. Okay, so for example, if I click here below, the console will appear here. If I click console, the console will be positioned down here. So let me go back to that one, console here. So my console is now on the upper right portion. Okay. Okay, any questions so far, class? I would appreciate you chatting yes if the in answer to my questions, if it's okay so far. Thank you. Yes, thank you so much for answering. How about the rest? Let's make it a practice, guys, for you to respond to my queries. Thank you so much. All right. Now, as I mentioned a while ago, this is your YAML, this one. And we can put some instructions here on how our data will be knitted. But let's not discuss that now. Our interest Our interest is more now on discussing what data classes are and data structure. So let's first deal with data classes. Okay, so data classes are types of or classes of data, and they can be numeric. Data can be numeric. Data can be an integer. Data can be characters, okay? Or it can be a logical value, or a complex number, or even a data type, DATE. So let's give some examples. Now you recall that in our Markdown, codes are written in code chunks like this. So if you recall, the long cut is that's backticks. That is in your above your tab keyboard, okay, and then curly brackets, and then you have to put R, and then best to give it a name. So we can put here data classes, all right, and then space, and then close the three backticks there. But we don't want to do that because that's quite that we're wasting time in doing that. And there's a shortcut to that. And if you recall, the shortcut is, Control plus Alt plus letter I. Or in Mac, if you recall, in Mac, it's I think it's Command, right? Command plus Options plus I. Okay, so let me do that under data classes. Control Alt I, and there you have your shortcut. There you have your code chunk shortcut. All right. So may I again once again? Okay, thank you, Angel. You're correct. So may I ask the class if they were able to construct a code chunk using the shortcut? Command Option I is for Mac. Okay, thank you. Thank you so much for your quick response. How about the others? Yeah, I'm not having yet a. Okay, thank you. Hopefully, my 100% na participation tayo, except for those who can follow along because they're using iPad. Okay. All right. So let's take a look at some examples of data classes. Now, for example, the number 23.5. This data is called a numeric data. So that's numeric. And in other programs, in other softwares programs, it's called a float. So for numeric, it can carry decimal places. Okay, and it's different from an integer. So how will an integer be expressed in R? Okay, how do we express an integer in R? To specify that a certain data be treated as an integer, you put, for example, 23, and then you put the letter L there. So 23L is an integer. 23.5 on the other hand is numeric. Let's test. Let's see. There's a function in L called class that will tell us what type of data this is. So if I put class 23.5, it tells us that this is numeric. Okay. On the other hand, if I put here class 23L, okay, so it tells us what type of data that is. It's integer. Okay. How about class? So let me just put here class. If I just put 23, well, what will it be? Okay. So even if that value does not have a decimal point 0, it will automatically be treated as a numeric, which means that it has the capability to take on decimal places. On the other hand, yung 23L, talagang integer lang siya. Hindi siya pwedeng mag-decimal place. Okay? All right. So, aside from either numeric or integer, okay, what other data types do we have? Data classes. Any others? We can have what we call characters. A character variable or a character data. And a character data begins with a quotation, and let's say Bob or our studio. Our studio, okay, quotes also. So this would be regarded as a character. Okay. And let's see class. And let's copy this. Control C, Control B. Oops, Control G. I copied the wrong controls. Oops. My mouse is having a problem. Control C, Control D. Okay, there. It's a character variable, character data. And later on, we will learn that there are also several types of character. Okay, character can be just plain character, or it can be used as a factor or an ordinal factor. I'll explain that later. All right. So that's a character. Now, a data can also be logical. Logical. So what's a logical data, or others call this Boolean? Another name for logical is Boolean. Let me see my chat dito. Yeah, it's okay, Carlos. It's okay. So when you chat class, unless it's something that you only want me to, you want to see the chat. Okay, kindly share also your chat with the others. Okay, for those of you who are not followed because you're not able to run R, okay, don't worry, because this is recorded and then I'm going to post it so that if you are able to address your concerns with your R, then you'll be able to follow along. All right, so we have logical. And what's a logical value? Logical value can either be true or false. So we have true. Notice that it's colored, whatever that color is, pink. So that means, okay, this is not a character. Unlike the character here, which is colored green, right? Our studio is colored green. This one, true. It's a logical value, logical data. So if I type class and then class true, then this will give me, okay, a logical data. Now, if I type class and then put it in, let me copy this, Control C, Control V, class, and then put it in quotes, then notice it's already colored green. So this ceases to be a logical value. Rather, this is now a character value because of the quotes. Okay, so please just be aware of that. Now let's see, what if it's TRUE? Okay, what if it's just only T is capitalized? Let's see. All right, error. So this is neither a character variable, neither logical. If we put here a quotes, then this becomes a character. All right. So a character data has to be enclosed in quotations. And this is not considered as logical because a logical value has to be all capital true, or another way to write, okay, let me let me come up with another one. Okay. What about if it's just T? Okay, class, and it's logical. So the word true that will be considered as logical, or the word, the letter T, also can be considered as logical. So either or, no? Either or. Now let's see. Class of false. So you can see again that this is logical. Also class of F, capital F. Okay, so let me run this line. Okay, so they're both logical. Okay, so they're both Boolean, Boolean data. So what else? What other data classes or data types do we have? So another type is, so let me just write here, complex numbers. So what are complex numbers? Anyone, do you recall your algebra? What are complex numbers? You recall, class, your algebra? Okay, complex numbers are those with the real component and the imaginary component. So for example, 100, or let's make it square root of 100. It should be in small letters. R is very sensitive. So square root of 100, let's just run this. So it gives us 10, right? And then we add plus 3i. If you recall from your algebra, I is an imaginary number and it's equal to the square root of -1. Okay, so I is square root of -1, and let's get the class. Let me just type here class, and then let me copy this. So what's the class of this expression? And then run this line. Okay, so you now can see that square root of 100 plus 3i is 10 plus 3i, and then that it is a complex number. Okay, it's a complex data, right? Okay, and then another one, let's see, dates. Dates are very important for our subjects. Date and time. Okay, so let's see, 2023/01, January 19. Okay, and then let's type class, small letters dapat, class. It cannot work with big letters because R is sensitive to cases. Okay, all right. So let's run this, highlight anywhere in this line, and then Control Enter, or you can highlight this and then click here, run. Okay, Control Enter here. All right, so you can see that 2023. Okay, so something's wrong here, 2003, and then this is being read now as numeric. Okay, so if we want this to be as date, we should write here as that date. Okay, as that date, and then let's just copy this. Control, no, here. Control C, Control V. Oops. Okay. Here, I said as that date, 23/01/19, and then class of as that date, this this data. So let's run this, Control Enter. Okay. All right. Could not find the function as that date. It means the as that date function is from a particular package. So we need to access that package. Let's see, as that date. Okay. It should be capital, no? As that date. Sorry. It means that this is wrong. It should be capital letter. Let's check this. Control Enter. Okay, still an error. That numeric origin must be supplied. Okay, so let's see. Let me again seek the help whenever I run into errors like this, because normally some functions I don't memorize. I will only use it not always or infrequently. So when that happens, I will need to check, double check. Also because R sometimes deprecates old functions. For example, that function as that date used to work before, but now it doesn't. So it means that it has been overturned or it has been replaced by newer functions, which I'm not aware of. So let me just check here as that date. All right, and it brings us here to let's see, as that time. Okay, here it says as that time. Okay, here as underscore date. So this as underscore date. So if you take a look at this, let me pause for a while. Do you see this, guys? The class, the help pages.
Yes, sir.
Okay, I hope you typed here double question mark as that date. This is using question mark, or let's see. Let me just illustrate to you. If I use just one question mark, okay, sometimes it makes a difference. Sometimes it will allow one question mark. Sometimes it will allow you will have to use two question marks, especially if you're dealing with a package. Okay, so this is okay. All right. As that date, so this should work. Okay, so take a look at this. So we're learning how to navigate through some functions. Okay, as that date, you have here X, and then try formats. You have to specify the formats. Okay, X here is the object to be converted. And then you have to specify the format here. Try the formats. Okay, and then we have here usually some examples. All right. So let's take a look at this. Okay. So this one has that date. Okay. And then you have January 1, 1960. And then this one is the format required. So it should be day, and then month, and then year. There are different types of format. So let's copy this and let's include this. Control C. Let's include this in our function here. Okay. So take note of how the date is written here. Let's see if it will be okay. So this is okay. So we're using as that date. The object is 2023-01-19, and we want it to be written as percentage, percent day, percent month, and percent year. So let me first run this. Okay, still an error. Character string is not in standard. Okay, so it requires that the date should be in this form. Okay, so let's run that in that. Let's write that in that form. 1. Okay, 19 January 2023. Okay. and then put it in quotation. All right, so this is how you learn, class. This is how you learn through practice coding in R. If you encounter a mistake, you can go to the help function. You can type question mark or double question mark and type in the function that you're looking at. Okay, so let me run this. Control Enter. All right, so now it has been converted into a date. Okay, this one. So, okay, maybe. Okay, so if I copy this, Control C, and ask for the class. Okay, here I'm asking for the class of that as that date in this format, and then let's see, Control Enter. Okay, and it's now a date. Okay, don't worry, guys, if you're getting confused. we're going to learn more about this, especially when we go to time series. Okay, so let's just have a quick review of what we have discussed so far. So what are the different data classes or data types that we have looked into? We looked at numeric or float. So this is a number that can take in a decimal place. You can write a number without the decimal place. That will still be treated as numeric. Now, unless you impose that it's integer by attaching L to it, then any number, even without the decimal, say like 1. Okay, so let me just type here 1, semicolon, class. Okay, class of 1. If I run this here, see, so I wrote number 1, and then the class of 1 is numeric. Okay, if I want that to be if I want that to be a integer, I have to put L there. Class 1L, and that will give us an integer. Okay, so we discussed the integer, we discussed the numeric, and then the character, they have to be placed in quotes, single or double quotes, that will be fine. Okay, and then a true data takes the values of true or false. Okay, you can write it as the word true, or just capital letter T, or the word false and capital letter F. Any other form not according to this one will be construed as either error or just a plain character. And then we have complex numbers, okay, and then the date and time. Okay, this is quite tricky, the date and time, but we're going to deal with this in the future. All right, so let me pause for a while. Any questions? I would appreciate your chat if you're able to follow along, and if everything is clear so far. Okay, thank you. Okay, good. Appreciate your comments, your feedback. Okay, good. Speed natin, okay lang, ano? All right, thank you. So let's move on. Okay, now let's now discuss. Okay, by the way, this one hashtag means that this is the main heading. If you recall, I discussed in class, one hashtag will mean that's the main heading. So let's use 2 here. Okay, let me use 2 here. So assigning, okay, no, create, create. Let's now create objects in R. Okay. All data, all whatever type it is, can be inputted in R. Okay, and once the data is inputted in R, that becomes what we call an object. So an object can be a number, it can be different numbers, it can be letters, it can be character, it can be a set of logical values, a set of complex numbers, or it can be a combination of this. They're what we call objects in R. So let's do some examples on objects in R. Okay, so notice that this has two hashtags. It means that it will now be under this main heading. So here you have data classes. You can just remove this. And then under that, number 2 is objects in R. If I have another number 1 here, so this is another main heading. Okay, so this is another main heading. And how do I know that? If I take a look at the outline here, notice now that there will be on the side, you will have this outline. And you can see here, these main headings are 1 hashtag, okay? And this one is 2 hashtag. So everything here, that's all capitals. So that's your main heading. Of course, we can change this because there's so many main headings and not subheadings. Okay, that's not a good way to do an outline. Yes, Stefan, please.
Wait, sir, how did you open that window?
Here in this
outline.
tab, you can see here the outline. Okay, and then just click this. You'll find this.
Okay, thank you, sir.
Okay. Okay, thank you, Stephen, for that question. Any other questions, class? Okay, please, I would like to encourage you, just like what Stephen did, ask questions. Okay, let's see. Okay, thank you, Margaret. All right, so let's continue. Let's now do, how do we create objects in R? So let's create another code chunk, Control Alt I or Command Option I. All right. So let's create, let's have an object and let's assign, let's say 100. Now we know that this is a numeric data, okay? And let's give this a name. It's like giving this the name of an object or a variable. Let's call it, let's say J equal to, okay. Here you have we're creating an object called J, and the value of J is 100. Okay, so let me show you first. Now, below in our environment, we do not have any object yet because we haven't created an object. Now, when we create this object J and assign a value of 100 to it, and if we run it, you'll notice now that in the environment, you have this object J equal to 100. Okay, so what's the purpose of that? We can now use J and perform any functions with it. For example, okay, J times, let's say, square root of 52, for example. So can we perform this? Let's see. Let's run this. Control Enter. And you notice now that there's a value there, 721. So it just performed J, which is 100, times the square root of 52. Had I used, let's say, E, okay, times, let's say log of 25, okay, this will return an error term because R will not recognize what E is, okay, because there's no object here called E. So if I run that, there error, object E not found. Okay, so all objects in R are reflected here, whether it's a set of data or just one number or one letter. Okay, it has to be found here. Otherwise, if it's not found here, then you cannot perform any operation out of that. Okay, so let's create another object. Okay, let's create another object. Let's call it let's say F. Okay, any letter. Okay, this time I'm not going to use E. Okay, now you can use E. However, it's better to use what we call an assignment operator. Okay, we're going to use an assignment operator to designate the object assigned to this letter F. Now, why is that so? Because F is oftentimes used in equations. So we don't want, as much as possible, to use equal sign and assign it to a variable here. the best way to use an assignment operator is the less than or equal sign and then minus. Okay, so this is what we call an assignment operator. Okay, and how do you do this? Well, it's a less than sign and then minus. Or this assignment operator can also be alt minus. The shortcut for this is alt minus, or I think option minus for Mac users. You can use option minus. For Windows users, alt minus. So let me remove this. Okay, and let me use alt minus. So there, it's more convenient. I said do two keys lang yung, we're only going to press two keys, alt and then minus. Whereas for the other one, less than, you have to you have to press shift and then the less than symbol and then minus. Okay, I hope this is clear. Okay, and then we can assign several numbers here, C, and the way to do it is use the symbol C, which is to concatenate. Okay, so C stands for, okay, okay, let me okay, I commented this out. See, I used the hashtag sign to indicate that this is a comment. So we're just using this, okay, as a comment. So let's now create our assignment operator, and then C. Let's have 1.25, 3.46, 75.92, 3, 6, and then 4.5. All right. So here we have it's called a vector, which I'm going to explain later on what a vector is. It's just a list. It's just a set of several numbers, numerical. Okay. We know these are numerical data. How do we know? There's no L in the numbers. If there are no L's in the numbers, then they are numeric. They're not integers. Okay. So let's run this. Let's either control enter or do not run this because it will run everything here. We just need to run this particular line. So anywhere you are here, it's okay. On this line, you can be at the beginning, you can be at the end, you can be at the middle, and then press Control Enter. So now you have this. Okay, you can now see that we have this object F, and it's numerical, and there are 5 elements here, 1 up to 5. So you have 1.25, etc. So whatever we coded here is now present here. It's now an object. So we can actually now perform some operations here. Let's see. Why don't we use F and then times 2? Okay. What will happen if we do this? F times 2. Okay. All right. You can see now that F times 2 is, it just multiplied 2 to each of the numbers there, right? 2.5, 6.72. And as I said, our markdown will also generate the output in your script window and also in the console. Okay, so this is convenient because you can also see the output here in your console on the right side. Okay, so we were able to do this operation because F is an object that exists. Okay, so an object can be just a single value. Okay, a single data, can be numerical or character. All right. So let's check here. Okay, let me just put here. So we have this object J, right? And J is only one number. Okay, it's actually a numerical value. And if I ask what's the class, so the class function will tell us what kind of data that object is. So class J, and let's also take class E. Okay, so let's take the classes of these two objects. Control Enter. Okay, class E. Oh, sorry. Yeah, E is not existing. Okay, sorry. So let me delete this. So it returned an error term because E was not found. So if I, and anyway, I'll just introduce E. E is equal to, just give this a value 50 or any value you want. And I'll run this. So I now have E here, right? Okay, so I can now get the class of E. Okay, why don't we let's let E be equal to 50 times log of 25. Okay, so I run this, and E is actually 160.94, right? It's multiplying 50 times the log of 25. So if I get the classes of J and E, okay, you can see that they're both numeric there. J is numeric and class E is numeric. If I also included F, then it will also give us a numeric value. Okay. All right. So let's create another object. Let's call it K. And K is, let's see, it's a hello universe. This is the usual thing that they do in programming. Okay. K is hello universe. And we know that this is character. Control Enter. All right. So notice that it appears here in your console, also appears here in your console, but it does not print it. Okay, it's not reflected here. If you want for K to be reflected, you can use this print K. If we print K, then you have this hello universe. Okay, unlike this one, unlike J and E, the numeric one, which automatically is generated here in your console, in your script or source window, right? Okay. Or another way for you to automatically, if you want to automatically generate the printout, we can do this. Put your code in parentheses. There. Take a look at this class. You notice that I'm putting this expression K is equal to hello universe in parentheses. So if I run that, notice it automatically prints it. So the inclusion of the parentheses here at the start and at the end will generate the printout of this object. If I removed it here, and it did not print out in the console and in the source window. But if I placed parentheses there, okay, and Control Enter, there. Okay, and then we can ask for the class of K. So what type of object is K? Control Enter, and as expected, it's a character variable. Okay, clear so far, class? Let me pause for a while and ask for your feedback if the discussion, if this part is clear so far. Thank you. Okay, waiting for the others to to give their comments. All right. So let's see. Let's now generate another, will be a sub, okay, generate random numbers. 3 hashtags, which means this will be under the first heading, okay, will be under the first heading. Okay, so how do we generate random numbers? Okay, so if you want, for example, there's a function called rnorm. And if you want to know more about rnorm, we can do a question mark rnorm. And if we put that in the source window, you notice there's this line here, and put even a function there. There's still this. It indicates that there's something wrong with our. Okay, there's something wrong in this code. So if I run this, control enter. Okay, it did, no? So nag-generate siya dito, no? Okay. How about you guys? Were you able to? The question mark is actually a help operator. Putting a question mark there will mean that we're asking R for help about this function. May I have class your feedback if you were able to get help from the help window here? Did it generate this this help function, this help page? Okay, good. So maybe there was something wrong with what we were doing a while ago, because a while ago this generated an error term. Okay. Anyway, so here we can see that even if we don't put this inside the code chunk, it will still run. In this morning's class, we run this outside the code chunk and it generated an error term. So I'm not sure what happened. So what we had to do was to put this inside the code chunk and then it run. Or, okay, if you're doing some side coding, you can do it in the console. So putting it in the console will mean it will not be reflected here in the source. For example, if you don't want that particular code to appear in the source, so that when needed, it will not necessarily be here, then put it in the console. For example, if you just want to see a particular help in the help source of R, and then you don't want that to be needed in your document, then you can generate your function here, okay, or your help query here in the console. Okay, so here it means that this rnorm, this function, comes from the stats package. Okay, and you have here dnorm, pnorm, qnorm, and rnorm. So different types of functionalities, and it defines to you what these are, what's x, what's q, what's p, what's n, etc. I leave that to you for your perusal. So this comes from the normal density function, which is this is the popular Bernoulli equation, or normal distribution function, 1/√² of 2 pi times sigma e to the x negative x minus mu squared over 2 sigma squared. Very popular. This is the equation for normal distribution. And then here it explains what the dnorm is. It gives us the density. The pnorm gives us the distribution. The qnorm gives us the quantile function, and the rnorm generates random deviates. So we would want to generate some random numbers. So we're going to use rnorm. Okay. And below are examples. Okay, I leave you guys to make use of this. If you take a look at this, okay, so it's given an example. Take note of this. Okay, it uses a double equal sign. Okay, which we're going to study in the future. All right, so let me just leave that for a while, and let's go here and let's generate some random numbers. And let's first take a look at what's the syntax for rnorm. So let's copy this, Control C, and put it here, Control Alt minus, sorry, Control Alt I. All right, then Control V. So this is the syntax for our norm. And you can see that the default is the mean is equal to 0 and the standard deviation is equal to 1. And you know that this is a standard, no? Standard normal distribution from your stat. A standard normal distribution has a mean equal to 0 and the standard deviation equal to 1. So let me just comment this out, and then let's come up with another function, R norm. Okay. And the n here refers to the number of observations. Okay, let's create this object called L. Okay. Okay, let's just call it data, short for data. Okay, our norm, let's generate a total of 10 first. 10 observations, and then, okay, and then mean equal to 0 and standard deviation is equal to 1. Okay, let's include that first. All right. And let's use what we learned a while ago. Let's have R automatically print this data. Okay, since there are only 10, it can easily be printed below. So what am I doing here? We're creating this object called dot, and this dot is a composition of 10 values. They're normally distributed with a mean equal to 0 and a standard deviation is equal to 1. So let's see. Control Enter. Okay, so I have these 10 values of randomly generated, normally distributed random numbers. Now, may I ask you if we have the same values? Do we have the same values? Yes, thank you. How about the others? Do we have the same values or different values? You may chat or you may unmute yourself, please. Different, okay. Yeah, we're supposed to be different. We're supposed to have different values class because these are random numbers. Now let's create another one. Control Alt I here. And then let's also create our norm. This time let's create 1000 values. And let's have a mean equal to 50, and the standard deviation is equal to, let's say, 2.5. Okay. By the way, this one, Control C, Control V. Okay, I copied it. And then if I don't include the mean equal to 0 and standard deviation is equal to 1, it will default to this. Mean is equal to 0 and standard deviation is equal to 1. So even if I don't specify that the mean is equal to 0 and standard deviation is equal to 1, and just run this, it will generate, let me call this .1, okay, 10 randomly generated numbers, okay, all right, whose mean is 0 and standard deviation is equal to 1. Okay, so you can see here that if I check for the mean of, okay, let's put here mean of that one, and then standard deviation of that one, we're checking if indeed the mean is 0 and the standard deviation is 1, even if we did not specify here the mean to be 0 and the standard deviation to be 1. Okay, so let me close this first and then run that. Okay, so you notice that the mean is 0.03, quite close to 0. And the standard deviation is 0.62. It's quite a bit, and not quite close to 1. The reason for this is that you only have a few data points, only 10. But in the next example, we're going to use thousands of data points so that it will be closer to a real standard normal distribution. Because it's only 10, so it will really be difficult to generate a normal distribution which is close to having a standard deviation equal to 1. All right. So let's go here. Wow, how time runs so fast. Okay, here, our norm. Let's generate 1000. So let's create an object here called dat2. Let's call it dat2, alt minus. And then the mean is 50, and then the standard deviation is equal to 2.5. Now, if you want our data to be the same, we will create this function called set.seed. Okay, and let's give it a number. Let's say 1, 2, 3. This function will allow us to generate randomly generated numbers, but the same for all of us. Okay, and then let's include here a function called head dot 2, and then let's say 10. All right, let's take a look at this code chunk. The use of set.seed gives us same random numbers. Okay, it will generate the same random numbers for all of us since we're setting it to a particular seed. And then here we're creating this object called dat2, and we're using the rnorm function. So if we recall, this is from the stats package, right? Now, why were we able to use the stats package even if we haven't installed that package? Stats package comes with base R, so it means it's preloaded. So that's why we were able to use that stats package even without loading it to R. Okay, so one way to write this is here, stats. Okay, so what does this mean? This means that you're saying that this rnorm function comes from stats package. So this is useful, especially if you're using a particular function for the first time. If you don't know where that where the package came from, then it might be instructive to put where that package is coming from. Okay, in this case, we just to as a means of instruction for all of us. So this is coming from the stats package, and then you put this double colon, okay, rnorm. All right, and then this head function will generate the first 10 values of this data, this object .2. If you don't put any number there, the default will be it will generate the first 6 values. So let's just use this and then run this code chunk. Okay, and you will see that they generated the first 6. It generated the first 6 values: 1, 2, 3, 4, 5, 6, and I assure you 100% that we all have the same values. Can you confirm that, please? If we have the same values for that too. Okay, good. Okay, yes, thank you so much. Right. So we now have the same values, and it will be easy for us to work on this, and we'll get the same answers. Now, as I said, if I put here 10, okay, if I put here 10, control enter, it will give us the first 10 values. How do I know that this is 10? Take a look at the index here. The 1 here means that this is the first value. The 5 here means that 50.32 is the 5th value. The 9 here means that 48.28 is the 9th value. If this is the 9th value, therefore this is the 10th value. Okay, so we have the same. Okay, and how about using tail? Tail.2, and then let's have 5. So this will generate the last 5 values of the .2. Okay, enter, control enter. There. This is the last 5, and we should have the same. We should have the same values. 49.377 should be the last value. All right. Let me pause for a while, and please feedback, guys, if we are clear so far. Okay, only 7 responses.
Sir, ano po ulit yung tail?
Tail will give us the last values. Head, the first values. So if we can define the number of values that we want, okay. For example, .2, that's from our object .2, and then 10 here means that you print, R will print the first 10 values. Yung tail naman, it will print the last here. I specified 5, but we can skip that, and R will print the last 6. The default is 6 values. Okay. Who asked that question? Angel, ikaw ba yan?
Me po. John po.
John. Okay, John, can you please confirm if you get the same values as me here?
Yes po, sir.
50.78, and the last one is 49.377. Tama ba?
Yes po. Yes po,
Okay.
sir.
All right. So that's the function of the tail. Okay. So thank you, John, for asking. That's very good. I appreciate questions. Okay. So, all right. Julie, what do you mean by different? Julie?
Sir, I have many numbers. The first one is 49.77506, which is different
Okay.
from
Let
you.
me see. Your first one is 48, 49. All right. Did you run this? Set that seed 1, 2, 3.
Run 1, 2, 3.
Yeah, this one. Did you copy this? Set that seed. Did you put this?
Yes, yes. All the
Everything.
typing content is different. It's same. Sorry.
Yeah, everything here is the same.
Yes, yes.
Okay, so how did you run this? Did you run this code chunk? Everything?
Yes.
Could you do that again, please? Run everything here. And are you now getting 48.598?
Oh, it's same.
Yeah, it's same. It's supposed to be the same. Because
But I don't have the 50.78307, which is the 0.78307.
Where's that?
One after one. The fourth.
Oh, this one.
This one.
Did you write
Yes.
tail? Did you write tail?
Yes, I write there.
Tail date that too also?
Control.
This one is for the tail. This is for the last 6 values of that too.
Oh, but sir, a while ago there, DAT2.5,
Comma. It's not that. It's comma. Comma 5.
comma 5.
Yeah. So comma 5 only means that you print the last 5 values. If we print this, then you will not have 50.78. You will only have 49.37, 48.96, because it will only print the last 5. If I print that, see, I don't have the 50, because the 50 point something is the 6th to the last. Julie?
Okay. Now it's
The same. Yeah, okay.
Yes.
All right, but that's a very good question. Okay, that's a very good question. So the set that seed allows us to generate the same values as long as we use the same number. So it can be whatever number. Okay, using the same numbers and then coming up with a random number generator. And there are several functions in R that gives random numbers. It will give us the same random numbers. Okay, I think I only have one more minute. Okay, so let me just okay, so let's just get the mean of that to our data, our object that to, and let's get also the standard deviation of that to. Okay, you can put in one line several functions like this, and maybe let's put also the maximum, okay, of that two, and the minimum of that two. All right. We can put several functions in one line. Just put a semicolon to it, and then let's run this. All right. So you notice that here the mean is 50.04, and it's quite close to the mean that we wrote here, 50. The standard deviation is 2.5, and it's 2.47, the random numbers that we generated. Okay, if we had increased this, let's say 1 million, then the mean will be really close to 50. Okay, remember a while ago we just generated 10 observations and the standard deviation was quite off. Okay, it was quite far because there were only a few observations. But if we increase the number of observations, it will really be very, very close to the defined mean and standard deviation. Okay, and then we have 58 is the that's the maximum, yeah, maximum, and minimum is 42. All right. May I have just one last, just last 2 minutes, guys, for your, with your permission, last 2 minutes. May I?
Yes, sir.
Okay, so thank you. And let's take a look at the summary. Okay, the summary function dot two. What will the summary function give us? The summary function will give us, would you kindly run that and tell me what gave us? What did it give you?
So it gave the minimum, first quartile, median,
Correct.
third
Okay.
quartile, and max.
Yeah, we call this the 6-number summary, right? This is your 6-number summary, which includes the minimum, the first quartile, the second quartile, the third quartile, the maximum, and the mean, right? So let me just generate that also. All right, so there you are. Okay, minimum, first quartile, median, which is the second quartile, the median is the second quartile, the mean, and you notice the median and the minimum, the mean, the average, are very close to each other, which is indicative that indeed this is approximately or close to not a normal distribution. Take note, if you recall from your stat, that in a normal distribution, the mean and the median coincide or almost coincide. And lastly, let's plot this. Let's use a histogram. So the hist, okay, if you can see this, the hist function, okay, will plot to us a histogram. So let's quickly do that. Hist of that 2. And if we run this, Control Enter, it will give us the histogram of that 2. And take a look, it's practically a normally distributed data. Okay, all right, so it's already time. Thank you so much, class, for your patience. Next time we're going to try to finish. Of course, we're going to look at the different types of data structures. So let me just inform you that the different types of data structures include vectors, lists, matrices, arrays, factors, and data frames. What's important for us is data frames. Okay, so I'm going to, let me stop recording now. Oops, sorry. Okay, where's that?